All right, in problem 2, we showed that the integral on the right equaled 0.5, right? And they asked us to numerically solve it on the integral on the left equal to 0.5. So somewhere between 1500 and 2000, we were saying needs to be plugged in for n to give us a 0.5. And it took me some adjusting on my Desmos sketch to make that happen, to make this function go through those black points. So notice what I did here. I let the integral equal L. I want you to make some modifications to your Desmos. So it's equal to L. And then right down here, I'm saying the list of numbers is approximately equal to, or find me a regression that would be equal to. And remember, I was guessing that it's a logarithmic function. So I'm doing the compression and stretch vertically and horizontally to fit to those points. So I'm asking it to find A and B so that the logarithmic function is stretched and compressed just right to fit those points. And it does, it finds them, right? So now what I can do is, like in problem 2, how I was kind of hemming and hawing in video 1, how do I do this on Desmos, the solver feature? Well, I can just go to my graph now, and I can graph a new line, a horizontal line at 0.5. So they were wondering, you know, oops, I want to put y equals there. So let's go y equals 0.5. And then I can find where they intersect out here. And the population would be 1,648.721, right? So coming back over here, I could say I've now found exactly, you know, the population was, what was it again, 1,648.721. Now they're going to want us to do something with that number. So in problem number 3, they ask us to graph that. So I'm going to put that in at 1,600. Oh shoot, what was it? Oh wait, I got to click over here. So 1,648.721. 148.721. All right, now we're going to do 20. So what that means is I need to go back over here and I need to do an integral. So I'm going to go an integral from 0 to 20.05 dt, and that comes out to be 0.05 t evaluated from 0 to 20. So now I get 0.05 times 20. I didn't really show that clearly, like where did that 0.5 come from? That was when I stuck 10 in for the t right there, right? So now I'm sticking 20 in for the t, and we're gonna get 1 right there. So this is 1, and when you stick 0 in, 0.05 times 0, we get 0 there. So we've got 1, right? So now what we need to do is we come back over to our Desmos sketch and we change our horizontal line to be 1. So let's make that guy 1, and we find where it intersects on the graph. And that number is 2718. Oops, 2718. I gotta remember that number. 2718. I think it was 0.282. And so these points are getting plotted on our graph, but they're just so high up here on the graph, it's kind of hard to see. So I'll adjust it here in just a second, okay? Then we need to do 0. So if I go and I look at my interval, if I go from 0 to 0, that's going to be 0, right? So we're getting, as an answer for this integral, 0. But really what we want is we want to know when y equals 0. So where does that happen? At 1,000, right? Okay, so let's go down to our table and put 1,000 in there for that guy. So 1,000. And now we're going to crunch the y-axis so we can see those numbers up there. Where the heck are those numbers? There they are. Okay. Oof, man alive. And then I need to stretch out this axis so we can see those numbers a little bit more stretched out like that. Okay. What kind of function do we have here? Well, it looks like it's getting steeper over there. It looks like an exponential function to me. So to answer question number 3 over here, so question number 3, We're supposed to sketch it.
So what did we see? We saw like a dot here, we saw like a dot here, and we saw a dot up a little higher. So if we had to guess, we're thinking the function looks something like that.
All right. So what kind of function has that?
Graph shape, exponential.
All right. So let's see on question number 4 what they want us to do. Find natural log of n minus natural log of 1,000, where n is the value found in problem number 2. Okay, so let's go back here. And n in problem number 2 was, I think, let's look back at number 2. What was it again? Problem number 2. Our n right here was 16 something, wasn't it? So let's go back over here and let's do natural log of 16. Shoot, what was it again? It was 1648. 1648 minus natural log of 1,000. And they're asking us to look at something that's kind of interesting about this. We get 0.5, which is what we said our answer was, right? We said it was 0.5. So yeah. So if we had 1648 in there and we took the natural log, because they're trying to get us to make this conclusion. Let's go actually to the slide with problem number 4 on it. They're trying to get us to make this conclusion that the integral of 1 over p dp is equal to the natural log of p. And if we had 1,000 right in here, and we had whatever it was, 1648 up here, so we have 1,000, 1648, and we see that that's about 0.5. So that confirms that that function is the antiderivative of that function. So this is the antiderivative right here. Antiderivative. All right.